Hey everyone, my name is Germano de Carvalho, and I am going to show you today my high impact practice here at UWF, which was a research and experience. And I started a SERP, summer research program, and it ended on me doing research for the whole year, and still doing it right now, and I'll probably still do it until I graduate. So let me show you a little bit of what we did. So I did research with Stephanie Eager, Brittany Lee, and Asmi Mishra, and our advisor was Dr. Sikabagwe, and we did research on K-means clustering on Zig data. So let's see what that means. So some background information for you guys is we used a data set called UWF Zig data. It is a data set that stored network traffic information such as so let's say every single computer, tablet, iPhone, cell phone, it connects and it sends information and information comes back. So we got bytes coming in, bytes coming back. So we got like number of bytes coming in, number of bytes coming back. What part did they go in? What part did they go back? And all this information it's set like in where it was like collected and put on a database, so we could study it. And in this information we have normal traffic, and we also have attacks. And attacks can be many things. It can be password guessing. It can be an attack called discovery, where someone tries to identify weaknesses in a system or a software, and or an actual attack when someone goes and like change something in a software, in a website. And we wanted like to differentiate the attacks from the normal data just using this information, like how many bytes came in, how many bytes came back. And let's see how we did that. So we used the method called K-means clustering, which separates data points into groups of clusters. And first thing we did, so a database is many rows and columns. Like you gotta think of a database as if it is a Excel spreadsheet, and it has like many rows and many columns. So what we did was we made every single row become a point in a space, right? So every single row becomes a point where like the every single characteristic, every single feature, like how many, like I said, like how many bytes came in, how many bytes came back, they are like they define like where this point's going to be, right? And then we use K-means clustering to separate these data points into different groups. And then what we saw was here we have the attacks as red and the normal data as blue, and we can see that the attacks are together there. So their characteristics, like their features, are different from the normal data, and they're together there at the lower part of the graph. And then after we applied the K-means, we could see that they were in the same cluster. So using this new technique, we were able to differentiate attacks from normal data with an accuracy of 97.7% and precision of 97.59 and recall of 97.59. And it was pretty good. It worked pretty well, and our conclusion was the K-means clustering actually works on separating attacks from normal data, and the research being very successful. We are right now writing a paper on it, and next week I'll be presenting our research on NCUR. And yeah, it's been awesome. It's been great to work with Dr. Sikabagwe and all my teammates too. And yeah, that was my high impact practice.